let's look at powers of 10. So you should be familiar with working in base 10. When we're doing powers, we refer to this as the base and this as the power. And to get to 10 squared, which is 10 times 10, which is equal to 100. So 10 to the 7, for example, will be 10 multiplied by 7. 10 multiplied by itself 7 times rather, so that's 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7, which gives us one extra 0, which is 10 million. 10 million. 1, 2, 3, 4, 5, 6. Okay. The same principle applies when we are using decimals. So for instance, 0.1 is 1 divided by 10, and that's represented as 10 to the minus 1. So if we look, for example, at, let's say, 10 to the minus 6, let's use 10 to the minus 6, that is 1 over a million. 1, 2, 3, 4, 5, 6. And that can be represented as a decimal 0.123 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so hopefully you're familiar with base 10 and how we can represent decimals. So let's have a quick look at multiplying decimal numbers. Let's put a typo. Let's work in green. So of decimal numbers. Okay, so let's take a nice easy example. 2, 5, 6. Okay, so if we multiply this by a 10, for example, all the numbers move one space to the left. But the decimal point stays the same. So for example, this would become 12.3456. Now, this is sometimes represented like this. We can say decimal point moves one space there. Now, it's okay to say that, but you do need to recognize that really the decimal point doesn't move, and it's the numbers that move. That's a really important concept. But if that method works for you, then that's fine, but as long as you realize that it's not the numbers that move. It's not the decimal point that moves. Okay, so let's do some examples. Let's do 0.034 times 10. Let's do 1.236 times 10 squared. 0.00067 times 10 cubed. And 0.6732 times 10 to the 4. Okay, so pause the video and have a go at these questions. You can use a calculator to check, but hopefully you can do them without a calculator. Go ahead. Okay, so hopefully you've done that now. And you should be able to recognize that 0.034, when multiplied by 10, we can just imagine that the decimal point moves once to get 0.34. Okay, now this is really 100, because 10 times 10 is 100, so we need to move it twice, 1, 2, to get 123.6. Okay, so 10 cubed is 1,000, because 10 multiplied by itself 3 times gives 1,000. So we need to move this 3 positions. 1, 2, 3 to get 0.67. Okay, we've got 10 to the 4, which is 10,000. And that moves 4 spaces. 1, 2, 3, 4 to get 6734.2. Okay, so that should be solid. You should be able to multiply decimal numbers by powers of 10. Now let's try division of decimal numbers by powers of 10. Division. Now the same principle applies. So if we've got something like 0.3467 divided by 10, you can think of the decimal point jumping. Now, instead of getting bigger, if we multiply this by 10, the decimal point is going to jump this way. But because we divide him by 10, it's going to move the other way. Let's get rid of this. Okay, so let's move this in the other direction. It's going to move here. So 0.03467. Okay, so let's have a look at another question. And hopefully you can pause the video and have a go at these 3 problems. 2, 3. Let's do 0.0346 divided by 10 squared. 0.00124 divided by 10 cubed. And 1246.2740 divided by 10. Let's do 10 to the 4. Okay, so pause the video and see if you can work these out. Okay, so hopefully you've worked these out. So that is really divide by 100, because 10 squared is 100. So we need to rewrite this 0.0346, and the decimal point jumps 2 spaces. 1, 2. Let's get rid of the... Okay, now it's fine to pretend that the decimal point jumps, but in fact the numbers are moving. Okay, so hopefully you recognize that 10 to the 3 is 1,000. You can rewrite our number down again. Let's do a couple of zeros. 1, 2, 4. So our original number was there. And it moves 1, 2, 3. Okay, so that is a bit square. squashed, so I'm going to start this again. Okay, so let's write the number down, some zeros. So this is the original number. Let's put another 0. This was the original decimal point. So we're going to move 3. 1, 2, 3. Okay. Marvelous. Okay, so let's do the last one finally, which is 10,000. And let's write the number down below. 1246.2740, and it jumps 4 spaces. 1, 2, 3, 4. New decimal point goes there. Okay, so hopefully now you're confident about multiplying and dividing by powers of 10. Okay, so let's have a look at something called scientific notation. Let's put a new title, scientific notation. Let me explain the logic behind scientific notation. So in biology, sometimes we have very, very, very small molecules or cells which we would like to record in literature or no, just for factual reasons. So for instance, a cell diameter could be 0.000036 microns. Now, that is not convenient to write down in scientific literature. So we shorten this by saying that is equal to 3.6 times 10 to the negative 1, 2, 3, 4, 5, 6. Okay, so if we use another really big number, 467,000,000,000,000,000, and let's say that's the amount of bacteria on a chopping board or on a toilet seat, that number is really inconvenient to write down. So we would abbreviate that as 4.67 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's look at this more closely. So scientific notation is written, I'm going to write this in green, in the form of A multiplied by 10 to the n. And we're going to say that A is bigger than 1 but less than 10. And we're going to say that n is a whole number. So that's counting numbers 2, 3, 4, 5, so on and so forth. Okay, so let's look at some examples. And this is a really good, it's a really good method of learning this. And instead of writing the formula down, which is useful, we can look at patterns. So let's look at some numbers. 1, 2, 3, 4, 6, 7. Let's do 6821000, 7813000, and 2146 point. Let's do just zeros, and let's do a big one, 21. Okay, so I'm going to do the first and the last, and I want you to do the rest. Now, we need to write these numbers in this form. A multiplied by 10 to the n, where n is a whole number, and a is less than 10 but greater than 1. So let's do that then. We can rewrite the first one as 1.23467 times 10 to the 1, 2, 3, 4, 5. And that's the answer. I'm going to do the last one, and then I would like you to do the 3 in between. So let's do 2.1 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Okay, so pause the video and do the 3 in between. Okay, so hopefully you've done that now. So I'm just going to do these very quickly. So last one is 46 times 10 to the 1, 2, 3. 3, 4, 5, 6. Hopefully that works out. 1, 2, 3, 4, 5, 6. Yeah. This is going to be 7.813 times 10 to the 1, 2, 3, 4, 5, 6 also. And this is going to be 6.821 times 10 to the 1, 2, 3, 4, 5, 6. Okay, so hopefully you're confident doing these now. So let's have a go at writing some scientific notation in using numbers. So I'm just going to do 5 questions, and again I'll do the first and last, then you can do the rest. So let's do 2.36 times 10 to the 4, 3.18 times 10 to the 2, let's do 3.762 times 10 to the 3, let's do 4, 1.289 times 10 to the 6. Okay, so 2, 3, 6, and let's pretend the decimal point jumps 4 spaces. 1, 2, 3, 4. We add 2 zeros. Okay, so decimal point jumps twice. Nice and easy. Okay, so I've done the first and the second one. So you do 3, 4, and let's put another one in for you to do. Let's do 5 right down the bottom. 1763 times 10 to the 5. Off you go. Okay, so hopefully you've done that now. If you haven't, pause the video and do the questions. Okay, so let's have a look. The decimal point moves 3 spaces. 1, 2, 3. And this becomes 3762. Decimal point moves 6 spaces. This becomes 1289. That is 1 space, 2 spaces, 3 spaces. 4, 5, 6. Let's double check. 1, 2, 3, 4, 5, 6. Yep. That's okay. And then we got 1763. Let's double check. 1, 2, 3, 4, 5. Okay. Now, we've done large numbers, so let's have a look at doing small numbers. Let's imagine we've got to measure the thicknesses of the cell walls in some animal cells. A really small increment is called the micron. Okay, so let's have a look at some small numbers. 0, 0, 0, 0, 6, 7, 8. Let's use that as 1, 2, 3, 4, 5, and let's be ambitious and do 6. Okay, 0, 0, 0, 1, 2, 3. 0, 0, 0, 0, 0, 0, 4, 6, 7. 0, 0, 0, 1, 2, 3. 1, and let's do 1, 1, 1, 1. Okay, so I will do the first and the last, and I would like you to do the ones in the middle. Okay, so we need to write this in the form of A times 10 to the n, where A is in between 1 and 10, and n is a whole number. So let's do that. Okay, so we've got 6.78 times 10. Okay, we're going in the opposite direction now. 1, 2, 3, 4, 5. Negative 5. You must remember to write that negative. Okay, so this one's nice and easy. Okay. So nice and easy. I made a mistake. 1.1111 times 10 to the negative 1. Okay, so do the 3 questions in the middle and pause the video. Okay, so hopefully you've done those. So I'm just going to do them quickly. 1, 2, 3 times 10 to the negative 1, 2, 3, 4. This one's going to be 4.67 to the minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, we've got 1.23 times 10 to the minus 1, minus 2, minus 3, minus 4. And then we've got 1 times 10 to the minus 1, minus 2, minus 3, minus 4. Okay, so hopefully you're able to write really small numbers using scientific notation. So let's have a look at going from scientific notation to very small numbers. Okay, I'm going to do some examples. Okay, let's do 4 examples. Again, I'll do the first and last, and you do the ones in the middle. Okay, let's use different color. Let's do 1.46 times 10 to the negative 2. Let's do 2.89 times 10 to the negative 3. Let's do 1.76321 times 10 to the negative 4. And let's do 1.6999 times 10 to the negative 5. Okay, so I'm going to do the first one. So jumps 2 spaces, 00146. So that jumps 1 space, 2 spaces. Decimal point's going to be there. Put 1 additional 0 in. Okay, let's do the last one. We've got, put some zeros in. One, 6, 9, 9. Okay, it moves 5 spaces. 1, 2, 3, 4, 5. Okay, so you do the ones in the middle and pause the video. Okay, so hopefully you've done the ones in the middle. So let's write the number down. We've got 2, 8, 9, and it jumps 1, 2, 3. Let's do 1, 7, 6, 3, 2, 1. Jumps 4 spaces. 1, 2, 3, 4. Okay, so you should be confident in writing numbers in scientific notation and writing scientific notation using numbers. So let's finish off by doing 5 questions. Okay, so I'm going to say, first question, let's write 1, 2, 4, 0, 0, 0, 0 using scientific notation. Then I'd like you to write 0.00000000987 using scientific notation. Then I would like you to write 1.267 times 10 to the 3. I'm going to abbreviate ordinary number. And then I would like you to write 1.493 times 10 to the negative 4 using a ordinary number. Okay, off you go. Pause the video and then we'll go over the solutions. Okay, so hopefully you've done that now. So remember, scientific notation is written in the form of A multiplied by 10 to the n, where A is less than 10 but greater than 0, and n is a whole number. Okay, so first one's going to be 1, 2, 4, and it's going to jump 1, 2, 3, 4, 5, 6 times 10 to the 6. This is going to be 9.87 times 10 to the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Negative 9. That is a 0. Okay, so we've got 1, 2, 6, 7 jumps 3 spaces. 1, 2, 3. So this is right. And we've got this nasty question. Let's write it down again. 1, 4, 9, 3. 0, 0, 0, 0, 0, and it moves 4 spaces to the left. 1, 2, 3, 4. So we're going to get our decimal point there. Okay, let's get rid of that. Okay, so hopefully you're clear on powers of 10 and scientific notation. I recommend doing lots of questions on this to familiarise yourself with the processes of scientific notation. This comes up again and again in maths, so you need to learn it now and be familiar with it in order to answer questions later on.